Welcome again. So in this tutorial, I'll be talking about the ADC subcircuit. This subcircuit is actually the circuit that receives data the into the whole system. So this is the data that comes in. The name here is data, and it comes out as data out here. This is where it's being fed into the rest of the subcircuit. This data out will be fed to the demodulator. So the actual essence of having this circuit is to synchronize the data that is coming into the circuit using a common clock. This is a clock out, a received data clock out. So my last tutorial on my website was frequency divider. So everything here, this is actually what I designed for my last sorry, let me repeat it. This is exactly what I did in that tutorial about frequency dividers. For you to get any frequency from the initial frequency, this particular circuit must be there. As I described earlier, you can go back to the next tutorial to understand it actually. And here is counting up to 9. As you can see, counts up to 9. Let me zoom in. So you can see here, it counts up to 9. Reason is, for the project, it's assumed that the clock frequency of the whole circuit is 200 megahertz, and we are trying to generate 10 megahertz from 200 megahertz. So that means the divider should divide by 10 times 2. That is 20. So if you divide 200 megahertz with 20, you get 10 megahertz. That is, we are trying to get 10 megahertz at the output here. So that is the clock that will be used for processing this our data here. So that same clock is what comes here. You can see where it came down here, and is used for clocking in this data. Is used for clocking in this data. You can see the clock of this RAM 8 comes from here and not the general system clock. So it's trying to synchronize the data input. So at the demodulator, we'll be using this clock instead of the general system clock. So we are counting by 9 because 200 megahertz is the assumed hertz of the whole circuit. So you divide it by 10, you get 20. Divided by 2, you get. Divided by 10, yes, you get 20. Divided by 2, you get 10. So that's that. And instead of counting to 10, you count to 9. So that on the 10th count, that is when this is being triggered. I want to explain this whole frequency divider circuit. Is my last tutorial, I thought. So you can just go through it and understand how the frequency divider works. So it counts up to 9. On the next count, which is the 10th one, is being triggered, and this comes on, and again it goes off. So you know that for a single pulse it should go on and off. So if it comes up on 1 and clicks again to go off, that means it takes two triggering of this for it to come on. So that's why is 10 instead of 20. You know, for you to get 10 megahertz from 200, you have to divide by 20. So now instead of dividing by 20, it's being divided by 10 because of half is used to turn it on and the other half is used to turn it off. So it was now divided by 2 again to get 10. And within that 10, it won't count up to 10. It counts only up to 9. On the 10th count, it gets triggered. So that is how it works. Now, once the clock is coming on and coming off, it's now used to trigger this RAM that receives this data into this system. So once the data comes in, it's clocked in using this. So this is how this data comes in. So the essence of this whole circuit is to synchronize our input data with this clock out. So this is the clock out that we used to before processing the received input data, and it works at 10 megahertz. Now this is the negative output enable. Whenever is on, it sends signal to the circuit that is sending this data. It resets it. Whenever it's off, it's on. So it's a negative output enable to enable this to go in. So to come in from is going to the sub-circuit that sent this data in. So that is basically how this sub-circuit works. Please try and understand my last tutorial on frequency divider. That is basically what happens here. Then let's see. Okay, let me simulate it actually. So you can see, watch the clock and see what it does. Then you can find out that whatever I have in this data is what goes here per given time. Then let me be sure you can likewise see. So whenever it comes on, it changes. So that's how it basically works. This is our main circuit frequency, the one that works at 200 megahertz. And now this clock out, which is the one that goes into this place, is the 10 megahertz. So that's how we're able to generate the 10 megahertz from the 200 megahertz. Then let's see how it fits into the full sub-circuit. Let me remove this. So this is it. You can see this is the ROS data that comes into the circuit. The clock and the reset goes to the normal system clock and reset. But this is the generated output enable that goes into the circuit that brings in the data. And now this is the clock, the synchronizing clock here. So you can see where it went to. It went into the demodulator ADC clocking. So this is it here. So whenever the clock is being generated from the ADC, it goes in to this demodulator ADC clocking. So that is basically how this ADC sub-circuit works. So next tutorial, we'll talk about this FPGA sub-circuit, and then we go to PLC and then the BPSK modem. Thanks. Please, the codes to these explanations on my website, projectfpga.com/pbsk/code.php. Thank you. Subscribe to my channel.